Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel Paper Bowl, where we are solving past paper questions of IGCSE Physics 0625. Currently, we are on the topic of electricity and magnetism. So we've done a few topics up till now, and today we are doing topic 4.7 that comprises of questions related to electrical energy and power. So let's begin. But before we start, kindly like and subscribe the channel. And if you find anything helpful in my videos and the way I teach you guys, kindly remember me in your prayers. Thank you. So let's begin. Bismillah Rahman Rahim. Question. Acha, before we start, let me give you a brief overview. When we talk about electrical energy and power, what are the formulas that we should keep in mind? Okay, from work, energy, power, from that chapter, you know that power is equal to work done over time, or power is also equal to energy over time, change in energy over time as well. Okay, and obviously from this manipulating this formula, you know that energy is equal to power into time. Okay, so when we are talking about electrical energy and electrical power, we should know that power over here is represented with three formulas. One is power is equal to voltage into current. One is power is equal to I square R, where I is the current and R is the resistance. And third is power is equal to V square over R, where V is the voltage and R is the resistance. Okay. And we should keep in mind the fact that the questions, statements, the questions that you get, and in the questions which have resistance given, and you have to calculate the power, so you use these two formulas. Okay. In question statements where you have resistance given, okay, the power is calculated by these two formulas. And in the question statement that has voltage and current, so obviously you are going to use this formula. Okay. Now, once we've established that these three are the formula to find out power, what we need to understand is, okay, then what are the three formulas that are going to be used to calculate energy? Okay. Energy can be calculated using VIT, okay, because power is equal to VI, and energy can also be calculated as I square R T, okay, and energy can also be calculated by the formula of V square RT. Okay, तो power के ये three formulas you should always remember and keep in your mind. Okay, and I've just told you that the question statements which give you resistance and you have to calculate power, so you have to use these two formulas, I square R and V square by R. And the ones which have voltage and current, so you simply would use P is equal to VI as your formula. And the energy also can be found out by these three formulas. ठीक हो गया? Obviously, where you get resistance, though, you will be using these two formulas, and where you don't have resistance, just voltage, electricity, voltage, current, and time, so you will be using this formula. Okay. These formula for power are very, very important, and you should know them, and you should have an idea that how these formulas are made. I think now they've started to put these three formulas in the course syllabus, Cambridge syllabus on their website, that you have to know these three formulas in order to go through with your studies. ठीक है ना? So you should know them. Okay. Now, once we've established that, let's begin with the questions. Okay. Okay. Now, question number 1 states that a battery is connected in a circuit. It is switched on for 1 minute. During the time, there is a current of 0.40 amperes in the circuit, and the battery supplies a total of 48 joules of energy, which row gives the charge that passes and electromotive force of the battery. Okay. Now we know that um, that's right. I is equal to Q by T, where I is the current, Q is the charge, and T is the time. So here we know that we have to calculate the charge, and current is 0.40 and the time is 1 minute, but we have to convert it into seconds. So 1 minute is equal to 60 seconds. So 60 into 0.40 is going to give us the charge. Okay? So that is going to be 24 coulombs. Okay? And let's calculate the EMF of the battery. So for EMF, we can use E is equal to VIT. As a formula, voltage is given, EMF is given, and energy is given to us as 48 joules. We have to find current is 0.40 and time again is 60. So after you're done with the calculation, so you are going to get 2 volts is equal to V. So our answer is going to be C. ठीक हो क्या जी? Question number 2. The cost of electrical energy is $0.25 for each unit of 1 kilowatt hour. A 2200 watt heater is switched on for 48 minutes. What is the cost of this use? Acha ji, firstly we need to find out how many kilowatt hours do we have. So this is in watts and this is in minutes. So we need this to be in kilowatt and the time to be in hour. So if we convert this into kilowatts, so we will be dividing it by 1000. So this is going to be 2.2 kilowatt, and 48 has to be minutes hai, so it has to be divided by 60. Okay, so this gives us 0.8. Okay, so to find out kilowatt hour, we need to multiply 2.2 kilowatts into 0.8 hours, and this is going to give us 1.76 kilowatt hour. So now we have the total amount of energy that has been spent when this heater was switched on for 48 minutes. Okay, so up it's going to be simple, just like we calculate the rate. 1 kilowatt hour जो है उसमें 1 unit is for $0.25. ठीक है, and we have 1.76, so that is going to cost us 1.76 into 0.25, and this is going to give us $0.44. So A is our correct answer. ठीक है, almost all the energy questions are done like this. Question number 3. Which graph shows the current voltage characteristics for a filament lamp? Acha. As we know that when there is a current and a voltage graph for a filament lamp, the resistance increases and it curves towards the voltage axis. Like on the axis where voltage अभी यहाँ पे है, चूंकि voltage on the x axis, तो it's going to curve towards that. अगर ये इस तरह से होता तो it would have curved towards the voltage again. ठीक है, तो it always curves towards the voltage axis. ठीक है, as the resistance increases. So this is wrong, this is wrong and this is wrong as well. So one point you should remember that in a filament lamp, the current and voltage graph, the resistance increases and the it curves towards the voltage axis, so you will have no problems regarding this. Okay? Question number 4. There is a current I in a resistor of resistance R for time t. The potential difference across the resistor is V. Which equation gives energy E transferred by the resistor? So you always know that energy is equal to VI T. ठीक है जी? तो I V T भी ठीक होगा. So D is our correct answer. I R I V I R T गलत है. या तो ये I square R T होगा या V square by RT होगा और या फिर ये होगा. So if none of these are present, तो this is the correct answer. Question number 5. A student is designing a lighting circuit for a doll's house. He sets up 2 different circuits. Each circuit contains 12-watt power supply and 3 identical lamps. Each lamp is designed to operate at normal brightness when connected individually to a 12-volt supply. Okay, which statement is correct? In circuit 1, each of the lamp is at normal brightness. Okay. These 3 won't have normal brightness because they are connected in series. ठीक है? Normal brightness का मतलब ये है कि they all give out equal brightness. ठीक है? तो अगर अब यहाँ पर if we put on another bulb, तो इन सब की जो brightness है वो that is going to change. ठीक है? तो this is not correct. In circuit 1, if one lamp fails, the other lamps remain lit. नहीं, ये भी is not correct because in a series circuit, if this lamp is broken, so the other 2 are not going to work because the circuit is not going to get completed. ठीक है? In circuit 2, if one lamp fails, the other lamp remains lit. Yes, this is correct because in circuit 2, the lamps are connected parallel to each other, and when there is a parallel circuit, so if one of the component breaks, so the other components keep on working. Okay? अगर ये इस तरह से है, इसमें third lamp इधर है, so if one of the lamp stops working as well, so the others are going to remain lit. So that's correct. In circuit 2, the current from the power supply is less in circuit 1. The current ka we can't say that. वो तो we'll have to calculate and everything, but 12 volt की power supply है, तो it would be the same in both of these circuits. Question number 6. The table gives data for 4 different electrical devices. Which device develops the greatest power? Okay. When we are given voltage and current, so the formula for power that we have to use is power is equal to VI. ठीक है, तो we can calculate the power for this. So 12 into 3 is going to give us 36 watts. ठीक है? For these 2 values, the voltage is 110 volts and the current is 0.40 amperes. So this is going to give us 44 watts. For 400 watts volts and 0.10 milliampere. अच्छा, ये यहाँ पे किलो volts है और ये यहाँ पे milliampere है. We have to convert this into volts and this into ampere. तो ये बन जाएगा 400,000 and ये बन जाएगा इसको भी आप divided by 1000 करेंगे तो ये बन जाएगा 0.01 into 10 raised to the power minus 3. So calculating that would give us 40 watts. अच्छा, ये 240 है वोल्ट और ये है 0.20 एम्पियर्स, तो इसको हम मल्टीप्लाई करेंगे इस तरह से, तो we'll get our power to be 48 watts. So it required us to give us the device with the greatest power. So D is going to be our correct option. ठीक है जी? Okay, question number 7. The diagram shows part of an electrical circuit. The reading on the voltmeter is 16 volts. The current in the resistor is 8 amperes. 1 coulomb of charge flows from P to Q through the resistor. How much energy is transferred in the resistor? Okay. Now, to find out energy, we need voltage, current, and time. Okay. So, we have the voltage to be 16 volts. We have the current, but we don't have the time. Okay. And we have the charge over here. Okay, so we can find this out by I is equal to Q by T. So our current is 8 amperes. Charge of 1 coulomb flows through to T, and T is equal to 1 over 8. So that is going to give us 0.125 seconds. Okay? Once we have the time, we can put in the values in this formula. E is equal to VIT. V is 16, I is 8, and time we've just taken out to be 0.125. So this gives our answer as 16 joules. ठीक है जी? So this is our correct option. Moving on, question number 8. A water heater is connected to a 230 volt supply and there is a current of 26 amperes in the heater. It takes 20 minutes to heat the water to the required temperature. How much energy is supplied by the heater? Okay. We know that energy is equal to VIT since the question involves voltage, time and current. Okay. So we are going to use this. 230 volts is the voltage. 26 amperes is the current, and 20 minutes we have to convert into seconds. So 20 into 60 we'll have to do. Okay, let's write this over here. It's going to give us a 1200, I think. So the answer is 7.2 into 10 raised to the power 6 joules. Okay, G. So D is going to be our correct option. Moving forward, there is a current of 5 amperes in a resistor. The potential difference PD across the resistor is 24 volts. How much energy is transferred by the resistor in 1 minute? So again, we have our voltage, current and time. So we are going to use this formula for the energy. So 24 volts, okay, 5 amperes in time has to be in seconds. So 60 seconds, because it was 1 minute. So 1 minute is equal to 60 seconds. So this is going to give us 7200 joules. Okay, so D is our correct option. Question number 10. The potential difference across a car headlamp is 12 volts. The current in the lamp is 2.5 amperes. How much energy is transferred by the lamp in 1 hour? So again, we have to find out energy. So 2.5 amperes is the current and the time is 1 hour. So 1 hour has 3600 seconds. So calculating it is going to give us joules. ठीक है जी. So अब यहाँ पे आप if you look at the options, so this option C is in joules, but option D is in watts. So this is not going to be the correct answer. Don't look at the units kindly, okay, while you are giving your answers. Question number 11. A torch has a simple circuit with a 3 volts battery and a lamp. There is a 20 milliampere current in the lamp. How much energy is transferred to the lamp in 5 minutes? Again, we need this formula. ठीक है जी. So 3 volts and 20 milliampere. So we have to divide it by 1000. So 0.020 amperes is the current and time is 5 minutes. So 5 into 60 ho jayega ye. So when we are going to solve this and calculate it, so our answer is going to be Let me just solve it on my calculator. It's going to be 18 joules. Okay, so B is the correct option. Okay, question number 12. An air conditioning unit, a lamp, and an electric fire all receive electrical energy from the main supply. From which of these devices is all this energy eventually transferred to the surrounding? Okay, we know that in case of an air conditioner, the electrical energy received from the mains is eventually transferred to the surrounding. So air conditioning ke case mein this is correct. In the case of the lamp, we also know that this is correct. You've seen that many times. Everyone has a lamp in their house, so they've seen that. And electrical fire mein obviously this is going to happen. So it happens in all the three cases. So A is going to be our correct option. ठीक हो गया? Question number 30. A circuit contains a fixed resistor. The potential difference across the resistor is 24 volts and the current in the resistor is 2.30 amperes. How much energy is transferred in the resistor in a time of 17 minutes? So we need the energy. So we are going to use the formula VIT. ठीक है? So 24 volts. Current is 2.30 amperes and time is 17 minutes. So it is going to have to be converted into seconds. So 17 into 60. When you calculate it, it gives you an answer of 56304 joules. But the answer has to be either in joules or in kilojoules. So if we see that this is 5630, 5630 joules, and we have 56,304 joules. So we have to look for an answer that converts this into joules. So dividing it by 1000 is going to give us 56.3 kilojoules. Okay, so C is going to be the correct answer. You have to look for units in the question statement as well as in the answers. Okay, do look for the units. If your answer is correct and you have not looked at the units, so you lose marks. Kindly be very attentive about the units in the statement and the units in the answer as well. Moving on to question number 14. The diagram shows a circuit containing a battery, a resistor with high resistance, a switch, and a lamp. Initially, the switch is open. What happens to the lamp when the switch is closed? Asaji, when the switch is going to be closed, so the resistor is going to decrease because some of the current is going to pass through the resistor and some of it is going to pass through this switch. Okay, na? So the resistor is going to reduce. When the resistance is going to reduce, so this lamp obviously will glow with more brightness. Okay? It glows more brightly. It glows less brightly. It goes out. Its brightness does not change. No, it grows more brightly. Okay? And I've told you the reason for that. So question number 14 ka answer is A. Question number 15. The resistor of resistance R is connected to a battery of EMF V. There is a current I in the resistor. Power P is dissipated by the resistor and in time T the energy transferred is E. Which expression is correct? E is equal to IVT. हाँ जी, A is correct, which is E is equal to IVT. आपको पता है कि यहाँ पर अगर ये होता तो ये पावर का है और ये एनर्जी का है. वी नीडेड टू फाइंड एनर्जी ई, सो दिस इज करेक्ट. पावर का भी कोई भी जो फॉर्मूला है दैट इज नॉट करेक्ट. ठीक है, एनर्जी का ये नहीं होता, तो ए इज द करेक्ट आंसर. क्वेश्चन नंबर 16. 4 lamps are each labeled 240 volts. In which circuit do all the 4 lamps have normal brightness? So normal brightness means that all the 4 lamps glow with equal brightness. Okay? If you look at circuit 1, one of the bulb is um, connected parallel to three bulbs in a series. So they can't have a normal brightness. So A can't be it. Acha, option B may all the uh, bulbs are connected in a series, so they can't have a normal brightness. Option C may all the bulbs are connected parallel to each other, so they will have a normal brightness. D option, maybe two bulbs are connected parallel to two in series, so this is also not going to have normal brightness. Okay, question number 17. What is the unit of electrical power? Power का unit always is watt. ठीक है, electrical power जो है वो भी watts में ही होती है. Question number 18. Four lamps are labeled 60 watts, 230 volts. In which circuit are the lamps connected so that they operate at normal brightness? Already told you what normal brightness is. Normal brightness is all the bulbs glowing with the same brightness. Okay, equally bright होने चाहिए. So in this case, two bulbs are connected parallel to other. So this is not going to work. Two in series are actually connected to two in parallel, which are in series as well. So B may all are connected parallel to each other. So B is correct. If you look at these three are in series and then they are parallel to this one. So these won't have normal brightness. These all are connected in series. So this can't have normal brightness as well. Okay, question number 19. The circuit shown in the diagram contains an unknown component X hidden in a box. The voltage current graph for X is shown. So there is voltage, there is current. So voltage and current ka the gradient gives us resistance. So there has to be a resistor over here. Jiski voltage is being measured by the voltmeter and there is an ammeter as well. So this is going to be a resistor with a constant resistance. Okay, question number 20. The lamp is connected in 4 circuits in turn, each using identical batteries. The resistors are all identical as well. In which circuit will the lamp be brightest? Okay, the lamp has to be brightest. The lamp is going to be brightest in C because we know that when two resistors are connected parallel to each other, their resistance is less than the total resistance of these two resistors is less than the resistance of the smaller resistor. ठीक है, so this is going to reduce resistance. So this is it. यहाँ पे तो सीरीज में लगा हुआ है, यहाँ पे दो लगे हुए हैं पैरेलल टू वन इन सीरीज. सो इन दोनों को भी कैलकुलेट करके आप इनको एज सच पैरेलल के साथ ही कनेक्ट करके इनकी टोटल रेजिस्टेंस निकालेंगे एज वी डन इन द क्वेश्चंस बिफोर एज वेल. यहाँ पे दोनों सीरीज में लगे हुए हैं. दीज टू विल गिव द सेम इम्पैक्ट और यहाँ पर ये एक विल गिव something else. So C is the correct answer जिसमें दो resistors जो हैं वो parallel लगे हैं. Okay, this brings us to the end of our topic. So inshallah see you in another video related to these questions very soon. So before we leave, kindly like and subscribe the channel, and if you found anything helpful, kindly remember me in your prayers, and take care of yourselves until the next video. Thank you and Allah Hafiz.